It is nice to meet you, all of you. Welcome to our Internet of Things webinar series. This is the second activity. Today's webinar is on data-driven insights in the Internet of Things. My name is Bambang Susanto. I will be moderating this webinar. Firstly, let me introduce the main speaker today, Mr. Harshit Gupta. He is a senior research scholar pursuing a PhD in the Indian Institute of Information Technology, Allahabad, India. He is also working with University of Messina, Italy, and also Germany. His broad area of work is data science and machine learning. For all the participants, if you have any question, please keep your question until the end of the speech. Mr. Harshit Gupta will give the time to discussion about our questions. Or you can write the question on the chat room. Not holding the time any longer, Mr. Harshit Gupta, let's time given to you. Thank you very much for being with us. Time is yours.
So thank you very much, Mr. Bangmang.
Yes.
Now, as Mr. Bangmang already introduced me, so I don't think there is need to brief about me. So I am just skipping this uh, slide, but I would like to give you some details about my PhD research work, which I am going now these days. So basically, I am a PhD research scholar here in Triple IT Allahabad, which is a institute of national importance in India. And my PhD work is going with the supervision of Professor O.P. Vyas, who is here in Triple IT Allahabad, and Professor Antonio Pugliafito from University of Messina, Italy. So, in the supervision of these two professors, I am working here as a PhD research scholar and pursuing my research work. And as we have a big group of data science, so we also have some collaborations with different countries like Italy, Germany, France. So we have multiple projects in which we are continuously involved. So this the Triple IT Allahabad, where I am in right now, is a center of excellence in information technology, and which was established by the government of India, and it is we can also say as it is an institute of national importance, which was given to this institute after the Parliament bill, which was passed and which has declared Triple IT as a institute of national importance. So today our uh, discussion, the presentation, or we can say the session will be mainly revolves around Internet of Things. So the entire session will be based on the networks and the devices which are associated with the networks and which plays a crucial role in a modern era. So before starting, I would like to just take some talk with the students whether they have anything little bit idea about the Internet of Things. Uh, Anybody can tell, and whatever they know about the Internet of Things, or the things, or internet, or devices, or sensors, means the basic one, whatever they know. Maybe if I say a name of some student, Dantoro, Devina, Diana, maybe multiple names are here. So I will not call any specific one, but if anybody wants to share their views, their basic knowledge about them, that it would be good for me to proceed proceed ahead in that direction, that how much I have to go in depth in this particular area.
Let me first, Mr. Gupta.
Yeah, sure.
My name is Martin.
Okay.
Um, as I know, Internet of Things is we connect all, I mean, devices by network called Internet. So we use Internet as a connector to one devices to another, and we can control remotely. And yeah, we can. I mean, in a dashboard, we can control all the data uh, that we have collect using by devices. So
Okay.
we can get the real time data, and also we can maybe can give a feedback by when we get the input from the devices. Thank you.
Okay. Okay. Thank you so much. That's very good. So now we will start from this Internet of Things. So the Internet of Things is mainly, we can assume, as a mesh of network in which multiple devices are implanted, multiple sensors are implanted to sense anything. Suppose we want to know that whether there will be rain today or not. A simple thing. So how we can achieve this? Actually, we are not God, but we can do this in this modern technological era. But it cannot be done in a very easy way. There are multiple things behind this prediction, and these things comes: Internet of Things, data analytics, artificial intelligence. There are multiple concepts which plays a crucial role while predicting anything. So in this prediction, there is a very common thing which may predict very easily nowadays, that there will be rain in next 5 days, what would be the temperature in upcoming days, what would be the humidity in upcoming days. So all these are only possible because of Internet of Things, artificial intelligence. So Internet of Things is a system which is uh, which consists of multiple computing devices, digital machines, objects, even animals or peoples containing some devices. And all these devices have ability to transfer data over a network without any intervention of human being. Means we can assume as there is a device which can sense anything, like environment, like a blood pressure of a human body, like a temperature, like a light intensity, like a oxygen level of a human body, and anything. So that device can sense all these things and automatically transfers these sense data to some central server, to those servers we normally say as a clouds. So these data are sent to the clouds for further processing. Now, coming next to the things, what are the things? Things could be any device, like a smartwatch we wear, like our mobile phone which we generally use, like our smart TVs, like our smart sensors. Anything could be a thing which are connected to a internet and able to transfer the sensed data. So Internet of Things is a sensor network of billions of smart devices which connects people, system, and other application to collect and share data. And a very simple example of this is our smartphones. Our smartphones are also a internet of thing which connects people. We can talk on the smartphone, we can send some pictures, some voice, some videos, some data over the network from one person to another person. So here a picture is given where you can see the multiple domains, multiple applications, like a house, there is a car, there is a bridge, there is a village, there is a tower. Multiple things are given in this picture. And here in all these application domains are, we are representing the application areas of internet of things. Like suppose we have integrated a sensor in a bridge which continuously monitor how much vibration is happening with that bridge. So by knowing the vibration intensity, we can predict if there is any event going to be happen with the bridge, like the bridge will break or bridge will lose its wire, anything could be. So with the help of the collected data from that vibration sensor, we may predict multiple things related to this bridge. Similarly, a house is given where lights are smart lights are there, air conditions are there. So on the basis of the sensors implanted there, we may control each of these appliances in the home. Also we may make it automated with the help of internet of thing and artificial intelligence. Similarly, there is a car. We may say that it is a self-driving car which consists of some sensors which continuously sees the actual environment surrounding to it and predicts when to accelerate, when to brake, when to turn, when to not turn, all these things. Similarly, there is a uh, weather data which represent when there will be a rain or when there will be a temperature rise, temperature down. So all of these circumstances are only possible with the devices which are implanted in these different application domains, and such devices continuously sense data for further processes. So this internet of thing is not only limited to all these applications. Instead it is used in a very small task in our house only. Like it is a, we can assume it is a concept of connecting any device with on and off switch to the internet. Like we may on the AC of our home from mobile phone. We may operate lightning system of our home from our mobile phones. We may operate anything, like simple example is wireless headphones, which we control from our mobile phone. This is also a application of internet of things. Cell phones, washing machines, smart washing machines, wearable devices, or we can say that lamps, coffee maker. Means there are multiple kind of applications which can be controlled by the by some another devices, and all this is only possible with the internet of things, because whatever the application is given here, like washing machine, headphones, lamps, etc., all these are things, but they are connected with internet, means they can be able to transfer data. So if there is anything which is able to transfer data, it means we can control that thing by using those data which is being transferred to the network. Similarly, we have seen the smaller application of internet of things. Now just we can see that it's big applications like jet engines of the airplane, drill of an oil rig. So if There are multiple sensors are implanted on the engines of some big airplanes, which continuously sense its vibration, its sounds, its multiple things are there, by using which we can predict, we can check if there is any malfunctioning in the airplane jet engine or not. So there is very big usefulness of internet of things in jet engines also. So next, if we take the consumer oriented IoT device like a smart TV, the statistics is given like 25 to 35% of consumer worldwide own a television that can connect to internet. So as a television is connected to internet, so it is also a kind of internet of things, because in previous era we use antenna, we use dish TV kind of things for the different multiple channels to see. But nowadays, with the introduction of smart TV, we just connect to a with the internet, and we easily find our channels, like multiple things like YouTube, like Hotstar. Multiple things are there which we may get by connecting our TV with an internet. So uh, there are mainly three aspects of the internet of things, six aspects of internet of things, that is device connection, data sensing, communication, data analytics, data value, and human values. So device connection consists of those IoT devices which are integrated over some applications and their connectivity with internet. Next we comes to data sensing, where those devices sense data and store those data. After that, the communication stage comes, where those stored data are transferred to any cloud, any edge servers, or anywhere. After that, the fourth stage comes, that is big data analytics, where the obtained data from these devices are analyzed, and after analyzing the data, we comes to some result. By using, we do some actions which comes under the data value. And after that, human value comes, where we use these kind of systems for our personal use, like for any smart applications, for any stakeholder benefits. There are multiple things where all such things are used for any specific application area. So these were the six main aspects. Now we will see the seven important components of an IoT system, where there are IoT devices, networks, security, gateway, cloud, applications, and the user which uses those applications. So in actual, it is a circular kind of ecosystem we can see here. like like we have some smartphone, we are dealing with some IoT enabled applications. Then that information goes to those IoT devices, where it transfers the data using the network. And while transferring the data, some security policies are there which decides whether the data which is being transferred must be secure. Similarly, this secure data is transferred through gateway to a cloud, and from the cloud the data is accessed, and again user access those data which is in the form of application. So this is the seven components of an internet of thing ecosystem. So next we will see an example of internet of thing for a intersection movement assist. Intersection movement assist means there is a crossroad where multiple vehicles are going from one side to another side. So how internet of thing can be beneficial to reduce the accidents at crossroads? Maybe due to not following the traffic rules, maybe somebody comes in a wrong lane, maybe somebody has not stopped when it was asked to stop at the crossroad. So by using these internet of things which are implemented in, we can say, on in the vehicles, it will sense the nearby coming vehicles and ask the driver to stop their vehicle. So this internet of thing which is integrated into the vehicles will sense the nearby coming vehicles, and based on this received data in real time, the driver was supposed to stop his or her vehicle to avoid the collision. There may be the probability of collision, there may not be, but if there is some kind of any situation is going to be occur, then the driver will get alert, and on the basis of that alert, he or she will stop its vehicle. So IoT can be a very useful to avoid the collisions on the road. So that is also a very big application, very beneficial applications of internet of things. Now, so here we have got to know that what internet of thing is, how we can use this internet of things, and how much it is beneficial to us, and also what are the different application areas of internet of things. Now we have know that there is a device which can be integrated into any application domain, where such device will continuously sense data and will send to the server or any cloud. Now, next, the concept of data science occurs, which is mainly based on the data, and that data we will get from the cloud, which was sent by the internet of things. See, this is a series of work, so we will get to know the entire scenario one after another. So now when we deal with the data science, it helps us to derive value from the data, and this value is that which we have seen here. This data value means any outcome, any result, or any extracted information from the gathered data. So data science deals with the study of process that helps us to derive values from the data. And here in the case of internet of things, data is the information created or sensed by sensors, devices, applications, or any smart gadgets. Means whatever the information will be gathered, will be collected by these sensors or these devices, that would be further used for extraction of some important phenomena, some important informations. For example, if we see like a fitness tracker, which calculates, like normally we wear some smart watches in our hands, so that smartwatch continuously sends how much steps we have walked today. So on the basis of that and on the basis of other information, we may know that how many calories we have burned, how much weight we have lost, what would be the best time for our workout. There are multiple important phenomena which we can get from the gathered data by the IoT devices. As data is continuously sensed by these IoT devices, and there are billions of IoT devices today in the entire world which are continuously sensing data. You can assume that a temperature sensor which is sensing data, and it is sensing, if we do not go at a very granular level, we may think like if it is sensing a data per second. Means if a sensor is sensing temperature per second, then you may think how much that sensor will generate the data in one day. In a 1 minute, it will give the reading of 60 temperature. Similarly, it in a 1 hour it will give us the reading of 60 into 60, and in the 24 hour it will give us the total temperature as 60 into 60 into 24. So imagine if there is a sensor which is integrated anywhere for sensing the temperature, how much data it will release in the entire year, in the entire 5 year. And similarly, there are billions of IoT devices, and how much data they are generating, even we cannot assume. So, as per the research which has been done on the on such IoT devices and their generated data, it is expected that by the end of 2025, these generated data would be 73.1 zettabyte. You may find the value of this zettabyte in kilobyte very easily. So think about this, like how much data we have, and for any prediction of something, the data plays a very crucial role. So having a such amount of data, having a such a big data, we may predict anything, we can do anything. Like we can see in today's world, we have many artificial intelligence based applications which can do automatically anything, like a chat gpt. We can use chat gpt in any way, we can ask anything from the chat gpt and it will give us the result. We can prepare any content, we can prepare any image, we can prepare any video by using the artificial intelligence. And all these things are only possible with the data, because whatever the artificial intelligence will do, that will be trained beforehand. Means there will be a model which will be trained before using that application. So, and for the training of that model, such data are required very much. So data generated by these internet of things are used to monitor devices, machines, infrastructures like energy meter, elevator, airplane engines, bridges. And also these data can be used for predictive analytics to repair and replace before they break. Like suppose we have data which is being continuously generated by some energy meter, and like some temperature, like any other value, and on the basis of those collected data, we may predict if that is going to be malfunctioning or not, that is going to be deteriorated or not. Also, it is used to monitor natural phenomena such as meteorological pattern, underground pressure during a oil extraction, patient vital statistics during recovery from a medical procedure. So there are multiple applications which can be done from the data which was generated by Internet of Things. Now, if we talk about the data, or we can say that the big data which are generated from these Internet of Things, there are mainly four important V's. V's means volume, velocity, velocity, uh, variety, and veracity. So these are the four important aspects of the big data. Volume means there are vast amount of sensors data collected continuously. Means there are large number of data which is being collected from these large number of sensors continuously. Next, if we comes to velocity, which is data is coming in minutes, seconds, in and even in a microseconds. The sensors are generating data, or we can say that sensing data in microseconds. Means we can assume that how much data we would have if we have integrated a sensors for a 1 hour only. Similarly, variety. There are different types of data which are generated from the devices that may consist of images, audio, video, numerical data. Maybe there are multiple types of data that can be used for multiple kind of applications. And similarly, there is a veracity, means the collected data may contain some noise, may be inconsistent, may be incomplete. So before making any analytics on such collected data, there is a concept of pre-processing. Means before using these collected data, we use the process of pre-processing of data, where the noises are removed, where the data are made consistent and complete. And once we get these noise free and complete data, then we again go for any kind of applying any kind of data analytics into those collected data. So now from here, from taking the devices to generating data to how we use the data, this was till now. Next, we will see how we can use these data for predicting anything. For predicting anything. So that is only possible with artificial intelligence nowadays. Using artificial intelligence, we can we can predict any value, we can predict any circumstances, we can predict any malfunctioning of machine, we can predict any uh, stock market price. Anything is possible with the artificial intelligence, but the only condition is here is this, that we should have sufficient data related to those field. So it is a artificial intelligence, it is a rapidly advancing field of computer science and technology, which mainly focuses on creating intelligent machines which are capable of simulating human like cognitive functions. Means by using the concept of artificial intelligence, we can make a machine which can work like a human being. Like if we see in our industries, now multiple machines are there which has replaced the human being. Now these machines have taken the place of human being for some automated works. So artificial intelligence systems are designed to perform the task typically which require human intelligence, such as problem solving, learning, reasoning, perception, and language understanding. Nowadays, we can simply use the voice recognition. We can simply say something to Google search engine and it just give a search results. So we can say that this is the Google search engine is also a kind of machine which understands the human language and provide us the result. And that machine, that intelligence which was developed under this Google search engine was only due to the artificial intelligence. Now, autonomous vehicle, or we can say that the self-driving cars or self-driving vehicles are the prominent example of this artificial intelligence in action. In action means these are the cars which are continuously working without any human intervention. They are combination of sensors, camera, radar, lidar, GPS, and advanced machine learning algorithms to navigate and drive without any human intervention. Now, this artificial intelligence is a very big concept, and we can say that it is a very different domain. So, there is a very much to tell in this artificial intelligence, but here in this session, I am just giving the brief overview of artificial intelligence and the important aspects of artificial intelligence, which are very necessary to know us for making any kind of uh, functioning, for making any kind of predictions using internet of thing and their generated data. So this artificial intelligence is a very big thing under which machine learning and deep learning comes. So machine learning and deep learnings are a concept. We will simply see the machine learning, which is a concept of training a machine which can simply behave as like a human being, like just like a robot, which can perform like a human being. If we will ask the robot to perform something, the robot will do same as we have asked to do so. So this is the machine learning, which focuses on developing algorithms and statistical model that enables computer systems or any device to learn and make prediction or decisions without any explicitly program. See, machine learning and the programming which we do in computer science, these two are different things. So we should know what is the difference in between two. In programming, we generally give some set of statements like if there is a condition this, then we will do this. If there is a condition this, then we will do this. But here in machine learning, we do not provide some such kind of conditions. Instead, we trained a model, like there was some kind of event, like this was the data set, and on the basis of data set these were the outputs. So on the basis of the given data set, these models are get trained, and after the training they perform like a human being. So here in this machine learning concept, there are mainly three things. We can say that the three types of machine learning. First is the supervised machine learning. Second one is the unsupervised learning, and third is the reinforcement learning. So if we start with this supervised learning, it is a fundamental category of machine learning where an algorithm is trained on a labeled data set. So here algorithm is the we can say that a mathematical model which was programmed obviously in a using some coding language. So that algorithm is trained by some data set. And here the supervised learning, this data set is a labeled data set. Labeled data set means, suppose there are three parameters in a data, like temperature, humidity, and the output is rain. So on the basis of the value of temperature and humidity, if there was rain or not. So if there is 1 means there is rain, if there is 0 there is not rain. So in a data set, if it is given that there is some output also, then that data set is known as labeled data set. But if there is no label, there is no output in a data set, then that is unlabeled data set. So here in supervised learning, there is a labeled data set which consists of input data which is known as features and their corresponding target labels which is known as output value. The primary objective of this supervised learning is to learn a mapping from input to output so that the algorithm can make accurate prediction or classification on new and unseen data. So here in a data set where each point is associated with a known label or target value, this labeling is done by human experts, and also that can be done by automatically by the our sensors which continuously sense data. Suppose there is a weather station which consists of multiple sensors, like sensors to measure temperature, sensors to measure humidity, sensors to measure wind flow, wind speed, wind direction, and rain. Now suppose all these sensors are collecting data time wise, like at 1 p.m. the temperature was this, humidity was this, wind speed was this, wind direction was this, and the rain was 1 millimeter or there was no rain. Similarly at 1 1 2 o'clock, 2 o'clock there was data this, 3 o'clock there was data this. So if we have such kind of historical data of 1 year or 2 year or maybe 10 years, then we can make our model more trained on the basis of such data, and we can accurately predict what would be the next scenario, what would be the next weather condition in the upcoming days. So on the basis of these data, there are multiple APIs in the on the internet of thing, like AccuWeather, which is integrated in our most of the smartphones. By using that AccuWeather, we can see the weather condition for the next upcoming 5 days. So that is only done by this method. The AccuWeather has trained its model by some historical data and predicts the weather condition for the next 5 days. So there are two things which comes under the supervised learning, that is the classification and regression. So in classification, the goal is to assign data points to predefined categories or classes like spam detection, image recognition, and sentiment analysis. So we generally have seen that in our email boxes there is a folder named as spam, and whenever we will see that spam folder, we will get to know that the emails in the spam folders are not very related to us, are a kind of, there may be some fraud spam, there may be some advertisement, but there will not be anything which are very important to us. So how this happens, how this Gmail knows that whether it is a spam or not? So this was only because of the training of the model of this Google. And in that case the classification technique was applied, like if there is a, if mail consists of such keywords, then that will be spam or not spam. So if there are things in which we have to classify, like whether it is 1 or whether it is 0, whether it is 1, whether it is 2, or whether it is 3, or whether it is male, whether it is female, whether there is a sunny weather, whether there is a cloudy weather, if there is rain or not rain. See, there are multiple classes in which we classify the things, then that is known as classification. So here we will see like credit card, credit scoring, differentiating between low risk and high risk customer from their income saving. Like there are multiple credit card companies which offers credit card to their customers. But there's a very big thing before proposing a credit card to a customer. They find how much risk is associated with that customer. If the customer has used the credit card and not paid the bills on the stipulated time, if there is a customer who uses the credit card but pays the bill on the time, so if there is a good customer, then the risk associated with that customer is very low. But if there is a customer which do not pay their bills on due time, then there is a high risk of with associated with that customer. So how we will classify the customers based on their income and based on their saving? So we can make two kind of classes, that the low risk associated customer and high risk associated customer. So we may have some mathematical formulas based on their income and saving data set. So if income is greater than some specified value and savings are also some greater than some specified value, then the risk may be low. Otherwise we can say that the risk is high. Suppose that there is a income of a person, high income person, and which also do some savings, then he or she will use the credit card at some of their requirement and pays the bill on time. But if there is a customer whose savings are nil and also their income is not very much good, but and also if the income is good but they are not saving anything, so there is a chances that he or she may be able to pay the bills on due time. So the risk associated with such kind of customers would be high. So on the basis of such data set like the income and saving of a customer, and credit card companies assess the risk associated with the credit card holder customers. So this was the basic example of how classification is used in machine learning. So similarly, there are multiple applications of classifications, consist of face recognition. Like if we are searching for any specific person in a system, then the face recognition will be applied over there, where it will classify whether the given image matches with the bunch of anyone from the bunch of images or not. Similarly, character recognition, like if there is a we have written something by our hands, there are handwritten some letters, some contents, then the machine learning would be able to classify whether this handwriting is matches with the other person or not. Similarly, the speech recognition, the medical diagnosis, whether a person will contain heart attack or not, whether a person will have cancer or not, whether the person is have he's diabetic or not. So there are multiple things where the classification algorithms are used to predict some uh, uh, medical diagnosis or some characters, and there are many applications. So for this training and test images, I will let you know in some later stage. Now if we come to this regression task involves predicting a continuous numerical value. For example, a house price prediction. Now if we come here, uh, uh, if we say the price for a used car, suppose what would be the price of a second hand car, what we say generally, or a price of a used car based on its actual price and mileage. So if the mileage of some used car is very good and its actual price is suppose that x, then generally its second hand price would be less than x, and if the mileage is good, then maybe its price would be good. But if the mileage is not good, and the price is x, then on the basis of its reselling cost would be low. So on the basis of some continuous value prediction, the regression analysis is done. So for just to take another example of house price prediction, like if the house is the area of the house is 200 square feet, then its price would be this. Area of the house is 300 square feet, then its price would be this. So based on such statistical data, we generally use regression analysis to predict the value of something in continuous manner. So this up to here, this was the supervised learning where labeled data are used to predict anything. Now we will come to unsupervised learning. It is a second category of machine learning where the model is trained on unlabeled data to discover underlying pattern or structure or any relationship with the data. And unlike the supervised learning, which involves input output pair, unsupervised learning seeks to find hidden structure or representation within the data without any explicit guidance. So for this unsupervised learning, we can take an example of we can assume the example of something mm, uh, the clustering of suppose that there are students in a class, they might be having some different heights. So on the basis of height, we have to differentiate them. So what we will do, firstly we will just find out the students which are having long heights. So we will first we will first extract out them and side that the students are more than 5.5 feet, so they will get they'll get another position. Now the students less than 5.5 inch and but more than 5 feet, they will be extract another way. So on the basis of their heights, we just make clustering of the students so that we can find a pattern among them. Suppose that we have to find some anomalies in any anomalies in suppose that key anomalies in data, like if we are doing some password application, like we are try to log in some a website and we are putting our username and password. Now suppose we, if we know our password, then we will enter our email id and password very easily, like this is my email id and this is my password. Maybe we have forgotten our password, but we will try some password nearer to whatever the actual password is. But if there is an attacker, there is some another somebody who is trying to access the account of any another person and knows only his or her email id, then what he will do, he will try to write the password in different manner and multiple times. So the insertion of password by some attacker would be different than the insertion of password from the actual account holder. So on the basis of the pattern which is followed by the attacker, we can cluster those data, and we can find out that there is the attack on the account of some person and this is not the actual account holder. So on the basis of such data collected by the system for the insertion of password, we can cluster the attackers from there. So, and here in this supervised learning there is no labeled data, means we just only check the pattern, we just check the features what they have, but we do not have any classes, like it was in supervised learning, that whether a person is having some heart attack or not, this was class. But here in unsupervised learning there is no class, but we have only features, and on the basis of those features we do clusterization of the things. So there are different algorithms which are applied for the clustering, like k-means clustering, hierarchical clustering. These are the very common clustering techniques which we can use while doing some applications of unsupervised learning. So there are many applications of unsupervised learning also, like customer segmentation, like businesses uses clustering to group customer with similar behavior or preferences of targeted marketing strategies. Like if there is a customer who is doing some online shopping, and if there is a younger customer, what he will do, he will search for some clothes, he will search for some electronic gadgets. So on the basis of this searching pattern, the companies knows that the customer which is using this app is some younger person, and his choice, his preferences are clothings or smart devices, etc. Then on the basis of that, the company will start producing advertisement on the customer related to their medical field. So similarly, there are multiple applications of this unsupervised learning, like image and document analysis, recommendation system, like what kind of song we prefer to listen. If there is some the kids which is playing mobile, then he will play some cartoon in their mobile and some songs corresponding to some kids. But if there is a person, there is a customer who is finding some songs on YouTube of its own choice, the songs of any film, the songs of any movie. Similarly, if there is a oldest person, then he will try to find out the songs related to his choice. So based on this, these choices, the YouTube, the companies starts recommending him or her that you should listen this song, or you should see this movie, or you should buy something related to that. So all these are comes under the unsupervised learning, where there is no labeled data, but only the data which is collected from the customers. So this was the mainly unsupervised learning. Now we will come to this machine learning. So maybe okay. So now, till now we have got to know that what the sensors, how much and how data are collected, and how we can use it for some kind of prediction. Now we will come to actual machine learning process, like how it happens. So model training, what is the model training here in machine learning? So as I already told you that there are multiple algorithms in supervised or unsupervised learning which are trained to perform some specific course of action. Like if I have created a model which could predict the risk associated with a person for a credit card company, then that also comes in the comes in the machine learning, which gets trained by the customer data. So for training these models, the model training steps comes in the machine learning, where model learns some patterns, relationship and features from a labeled data set. And during this process, the model's internal parameters, or we can say that weights, are adjusted or minimized to make the prediction accurate. Like if I have given some data to some, here as it is given, like input and target data is given some machine learning algorithm, and after this training some predictions are made. Then this prediction is compared with the targeted value, and if there is any difference, means if there is a less accuracy in the prediction, then that value is again transferred to this machine learning algorithm, where parameters are adjusted, and again after adjusting the parameter the predictions are made, again it is compared with targeted value. And if the accuracy obtained is now better than the previous one, but it is still to be optimized, then this process goes on again and again until we get some accurate prediction, or until if the predicted value becomes equal to the targeted or actual value. So here this is the process shown for the model training in machine learning, where IoT devices are used. See here, these are the IoT devices which continuously sense data and sends to some data storage, which may be any server. After this data storage, the IoT data goes to this machine learning models, where the model gets trained with this data, and some predictions are made, and after that the evaluation of that prediction is done to check whether our model is performing well or not. If there is some ambiguity, if there is some error in the prediction, then this process reiterated, the training goes on and on until we get the good result, until our model converges. So here simply we can see the prediction of weather. Like a simple example is given. In the left side you can see a weather station which consists of some sensors which continuously sense data and store in the cloud. And this is the data set on the right side, which is given. Like on the 4th November, the maximum temperature was 41, minimum temperature was 29, humidity was 79, rain, there was no rainfall, and the weather was cloudy. Similarly for 5th, for 6th, 7, 8, 9, 10, these data were recorded by this sensor. Now you can see here, like on the basis of this maximum temperature, minimum temperature, humidity and rainfall, The outlook means we can assume at the weather is cloudy or sunny. So now this data will be used to train a machine learning model, and when a new data will be given to that model after the training, it will predict the outlook. For this is a labeled data where these classes are given cloudy and sunny. There are two classes here, cloudy and sunny, and these cloudy and sunny were based on all this temperature, humidity, rainfall, and also the date. Like there are different weather condition in the entire year. There are some months where winter happens. There are some months where the temperature is cold, when the temperature is high, when there is a rainfall. So also the role of time is very important in this prediction. So based on this date, temperature, humidity, rainfall, we can predict whether tomorrow will be the sunny weather or there will be a cloudy weather. Okay, so this is a very basic example of the prediction of the weather based on the data collected by the sensors, which are which are known as the IoT sensors. These are the IoT sensors which continuously sense data to the data logger, where by the help of networking system these data are sent to a some cloud where such predictions are made, and then these predictions are shown to the user on their smartphones. Similarly, we know that we wear some smart watches, and the smart watch measures our heart rate, our steps, how much. There are multiple things which corresponding to our smartwatch, and these data are stored in our smartwatch, and when we collect such data to some cloud server and apply some machine learning algorithms, then we may find the medical condition of any person who is wearing this smartwatch. So based on, suppose that the smartwatch has collected the value of heart rate. So if we will see that there is some fluctuations in the heart rate of some person, then we may predict there will be some disease related to heart to that person or not. If how much he is walking, how much he is sleeping, so all these values plays a very crucial role in predicting the health condition of a particular user. So this smartwatch also act as a IoT device for sensing data and sending to a central server for further prediction process. Now, the important thing is data science for IoT is dynamic. What is dynamic here? So before going to dynamic, we first will know about the static. The classical version of data science is static because it is primarily based on historical information. Suppose a company gathers data from its client about their preferences and need, and based on their collected data, the company creates some predictive model to understand what their customer will required in a future days, what their future customer will require, what would be their need, whatever they have collected the data. So based on that data they make some prediction. So this is the static data science in a static manner, means they have firstly collected data and then make some predictions and then make some policies based on that predictions. But here IoT, Internet of Things, has changed its behavior. Now the analysis has become dynamic, means we have, see, in a IoT we have some real time sensors which continuously read some data. Suppose we have some smartwatch which continuously reading our heart rate in real time. So if the sensor, the smartwatch reads that now heart rate is very high, so it means there is a chances of some heart attack to that person. So that would be done in dynamic manner, means dynamically it will it will sense the data, it will send to server, and the alarm will send or notification will send some another person to which that user has made that caretaker that the person is going to have some heart attacks. Or there may be, if we implant some sensors with some internet of things kind of device on the roads, then it will tell us there is a chance of some accidents, because all these applications require real time service. If we want to predict the accident going to be happen, if we want to predict the medical condition going to be severe for a person, we are require real time service, means instant service. We cannot only trust on the historical data, but also on the data which is getting in real time. So real time collection of data, real time analysis of data is done in the dynamicity of this data science. So this was all about the how data science is dynamic for IoT devices. Now this is so this was all about the Internet of Things, data, and how we do some machine learning models trained for prediction of some important application domain. Now, we will see the concept of Industry 4.0. Why I have taken this concept in this lecture? It is because this is the pure combination of all the things which we have known till now, like the IoT devices, data analytics, artificial intelligence. All these things are combined in the Industry 4.0. So, before going through this fancy definition of this Industry 4.0, we will just get to know what is this Industry 4.0. What is 4.0? We all know very well what industry is. Industry is like a place where there are multiple machines which are continuously manufacturing something, or preparing some products, where some services are giving. There are multiple things, or all comes under the industry. But what is this Industry 4.0? To know this, let's have a look of this stone floor mill. This is a floor mill which was used in very before, means maybe before 30-40 years before. This floor mill was used, but this we can assume this as a Industry 4.1. Now next, this water mill was started using, where water flow was used to rotate this shaft to run the floor mill. After this can be assumed as Industry 2.0. Next, we will see this electric grinding machine, where electric motor is now responsible for rotating this grinding machine for the same task. And now this can be assumed as Industry 3.0, and this can be assumed as a Industry 4.0, where there is a big machine which is continuously making the same process, but in automatic manner. There are multiple sensors, there are many automation in this machine, in which there is not very much requirement of human intervention. So see what we can think about. What would be its speed? What would be its capacity of producing any product? Very less. In this, the efforts are something related less, but its capacity would also be very not very high, but more than the previous one. Similarly, I don't think there is much human intervention in this, except for the switch on and off and pouring something into this. So also its capacity are now little bit high, and efforts are now also reduced. And now we can assume this the capacity of this producing the product per hour or per day, like it would be very high, and also there is not very much requirement of human intervention. And there are also multiple big industries where high quality, high produce high product producing machines are implanted, to manufacture the products. So this is the entire scenarios reflecting here in this industrial evaluation, that is industry 1.0, where machine equipments were driven by some steam power, water power. Industry 2.0, some electric energy were started using. Industry 3.0, where some PLC devices and robots were started using. These were the key changes. And now in industry 4.0, we can see that introduction of IoT, cyber physical system, and all real time intelligence, all these are now using in the industry to make the industrial process fast, efficient, huge, and with less human intervention. So this is industry 4.0, which is going through nowadays. So this is the complete, we can say that the aggregation of IoT devices, data, artificial intelligence, and Internet of Things, real-time intelligence, all things are now integrated in this industry 4.0. So there are some building blocks of this industry 4.0, which we have already seen earlier, like big data analytics, autonomous robots, simulation, horizontal and vertical system integration, Internet of Things, cyber security, additive manufacturing, augmented reality. These are the building blocks of industry 4.0. It means all these have a very crucial role in making industry 4.0. Let's, if we talk about the Internet of Thing, industrial Internet of Thing means there are multiple IoT devices are there. Cyber security, if these devices are generating some data, so there is also the chances of some attacks on those devices. And if there is attack performed on IoT devices, there may be some effect on the entire setup of the industry. So that's why these building blocks were identified and made like that. This will be the main building blocks of industry 4.0, and study of these building blocks are very much required, very essential to know about each and aspect of industry 4.0. So if any student or anybody wants to go more deeper into industry 4.0, wants to do some research, wants to know about the industry 4.0, then they have to go with these building blocks one by one, and then they will get to know what is the role of these building blocks in this industry 4.0. So there are some examples of the product evolution, which are connected and smart product like Philips Lightning, which are now connected with some mobile phones. You can just turn on and off these light bulbs with your phones. This is blood glucose meter connected wireless to a monitoring display devices, and can alert patient to trend in glucose level requiring attention. This is a Meditronics glucose meter, which is it is a small device which is integrated with the human body, and it continuously monitors that glucose, and on the basis of that it provides some error. And similarly, there are some shirts which are also containing some IoT devices which continuously monitors the heart rate, movement, and how much distance the person has covered. Similarly, there is some Babolet, which is a pure product system, play pure drive product system, in which some sensors and their connectivity is given in this tennis racket, which allows user to track and analyze ball speed, spin, and impact location to improve game. So this is a tennis which consists of some Internet of Things. Internet of Things means there are some sensors which continuously sense what was the speed of the ball, what was the spin of the ball, what was the location when we hit the ball, and on the basis of data that collected data, we can know that how we can improve our game, what should be our angle of it, what should be our speed of it, so that we can achieve our goal. So next is, which is related to this industry 4.0, that is industrial IoT. So as we have known right now that internet of things, but there are some IoT devices which are especially used for the industrial purpose. Means every device is not industrial IoT devices, but the devices which are mainly used for some industrial purpose, or any industry or any manufacturing company, or that is known as industrial internet of things. So it is the extension and use of internet of thing in industrial sector and application, which has a strong focus on machine to machine communication, big data and machine learning. It enables industries and enterprises to have better efficiency and reliability in their operations. So see here, the very interesting thing is given, like machine to machine communication. Like this industrial internet of things have ability to communicate with another internet of thing. Means if there are two devices are integrated in some industry for some specific kind of application, like we can say that there is a machine which is suppose that rotating, there is a generator which is rotating, and there is a switch which can turn on and off that generator. Now there is a one internet of thing, one sensor is integrated with that machine, which continuously sense the temperature of that generator, and another sensor is integrated with that turn on and off machine, which is responsible for making generator turn on and off. Now if sensor has sensor is sensing the temperature of generator, and it has sensed the very high temperature, then there may be the chances of deterioration of that engine, the generator may malfunctioning. So on the basis of that sensed data, it will instantly communicate with the sensors which is integrated with switch on and off, and at the same time the switch will turn off the generator. So this way of two-way communication or maybe one-way communication occurs between these internet of things in industry. So what is the difference in this and the human intervention in the industry? Like human cannot continuously sense the temperature of generator and turn on and off, but a device can do. So that is the important thing in industry 4.0, like what human cannot do but internet of thing can do. So those devices are known as the industrial IoT. So also they use the concept of machine learning for the training of those sensors. Like if the sensor has sensed the temperature maybe 30 degree, 40 degree, 60 degree, 100 degree. So and if we have trained that sensor that if the temperature is going something continuously 100 degree, or maybe if it is not going continuously 100 degree, 80, 100, 80, 100. So on the basis of such range of temperature or continuous temperature, there are some specific set of rules defined, which is done by these machine learning algorithms. So machine learning algorithms also plays a crucial role in industrial IoT and industry 4.0. Now you can see here the internet of things in this manufacturing, where there are multiple robots arm are shown, which is which can see that some product is now finished. Now it's time to uh, take up this product and pack it on some boxes. So these are the multiple areas where the IoT devices are working on, and the sensors are implemented on this. Even the robots, it is also a kind of IoT device, but to check the malfunctioning, but to check its good functioning or bad functioning, another IoT devices are also implemented into it. Like here we can see which continuously sense the health of the machines. So similarly, for the different kind of operation, the Internet of Things are used in industries. So there are some small IoT devices like some sensors or RFID devices. RFID device is used on some human being or any vehicle or any parts to continuously monitor uh, their condition or their data. By geolocating the sensor, one can see how people and products are moving. If there is a warehouse and some sensors are implemented on the person, on the vehicle, and on the products also, then we can track what is the movement of each product. Because like if we take an example of Amazon or Flipkart or multiple online shopping companies which consist of their large warehouses, so keeping track of each product in a warehouse is not a very easy task. So to do this, there are multiple IoT devices are used which do continuously monitoring of such products in warehouse for the smooth conduction of delivery process and the entire management of the products in industry or in any warehouse. Similarly, there is a this is also the part of that warehouse. When the product is like the smart inventory management, like if this is a kind of a trolley is given in which some products are kept. Now if that product is selling very fast and the inventory is low, below some threshold value, then it generates some alert. So all this is due to the Internet of Things, yani IoT devices which are implemented in this system. Similarly, RFID smart quality control is there, where RFID are attached to each product, which can use to tag defective products, good products. So there is also a good application of this Internet of Things. And this is a very good example of Siemens shampoo plant, where the different IoT devices are used on the each and entire setup of this shampoo plants, like on the bottle, on the smart dispenser machine, smart labeling machine. Okay. So by using these smart machines in the Siemens shampoo plant, the process becomes very fast and effective, and also reduce the human intervention. So this was the session which was all about the Internet of Things, its intelligence, its data analytics, and all. So that's all from my side from for today. So now the time is to discuss. If anybody have any kind of doubt, any query, and wants to ask something and curious to know something, then he or she may ask now.
Thank you very much.
Thank you, sir.
Amazing speech.
Thank you.
Okay, any question? Uh,
Yeah, Pak Bambang.
oh yeah, please, Mr. Joe.
Yeah, maybe I will try to ask to Harshit. Hi, Harshit. Nice to meet you this
Hello.
evening.
Hello.
Nice to
Hello.
meet you. My name is Johannes. So I'm
Okay.
one of the master students in data science. Harshit, maybe I would like to ask you. So currently now I'm trying also have some like some trial with the IoT, but I just want to ask and share with you. So, whenever we have the trials, and then, for example, yeah, in sometimes our sensors is cannot send the data. Then, for example, it should be you said in your previous slide, maybe in the beginning of your slide. This should be continuous. The data should be continuous, but if the data cannot be continuous because of some problem with the sensor, for example, the measurement is not well, and then some problem happen with the sensors. So, do you think that this kind of this case actually is also need to be fixed out, or is it still can use the data can use to analyze in analyzing? For example, if you want to use the predictions or the classifications, maybe that's my questions, Harshit. Thank you.
Okay, okay, that's a very good question. So that's the whatever you have asked. Like if there is a sensor which is continuously some data, and maybe due to some scenario, maybe due to some technical issue, maybe due to some any device issue, the sensor is stopped sensing. But after some time, it again started sensing. So in the due time when the data when the sensor was not working, we do not have the data. So see what happens, the this is the also this is the problem with the sensor. But it depends, if we are going for making any predictions based on that data, it is very important to know that what kind of application area it is. So if we suppose the sensor is related to some weather data, so it would sense the data in a time series manner, like it will collect the data time wise. So in the due time, if that the sensor was not operable, suppose that for the 3 hours, then it will not collect the data for those 3 hours. So if we will do the predictions by leaving the data which were not collected during these 3 hours, then it will not make any impact in our prediction, because the model will learn only those data which were present in that time, at the time when the sensor was operable. Suppose day on the day 1 3 to 5 the sensor was not sense the data, but on the day second it has sensed the data, the day third it has sensed the data. So whatever the data it will sense, that will be used for the prediction. And but if this kind of scenario happens very rarely, then there will be not any effect on the prediction of the model. But it happens continuously, then of course it is the very big problem. And then we have to check for the data before applying some then data analytics method into those data.
Oh, okay, okay, okay. Thank you. So it means that there is no such impact if the case is not continuously happens. Yeah. So it's just only for sometimes, or for example, just only for 2 2 minutes or 3 minutes lost in. For example, that one maybe is not really affecting.
No, no.
Comparing with the data. Yeah. But I'm just worried that maybe if we trying to analyze the data, it means that we need to continuously analyze. Then, if the data is lost, then it will be affecting. Yeah.
No,
Maybe
no,
okay, okay.
if it is rarely happening, then there is no effect on your analysis.
Okay, okay. Okay, thank
Yeah.
you, Harshit, for your explanations. Thank you
Okay.
very much. It's very helpful. Thank you.
Thank you.
Nice to meet
Thank
you.
you. Okay. So anybody else if wants to ask?
Yes.
Yes.
Okay, please. Next door.
Uh, First, hello, Mr. Harshit. My name
Hello.
is Nestor. I'm a high schooler from Jakarta. And first, I want to say thank you for your presentation. It was really interesting for me, really.
Thank you.
Actually, I have two questions. First, you said that the data that the IoT gathered is going to be sent to a cloud server or a
Ye-
cloud.
Yes.
If so, how can the privacy and security of the data be guaranteed? Because the privacy and security of data is a really big concern nowadays, especially here in Indonesia. And my second question is um, a little bit unrelated, but I still want to ask. As a high schooler who plans to study data science, what expertise or program should I study in advance to get better ability in data science? Thank you.
Okay, so that's a very good question, Nestor. So the question for your first question related to the security and the privacy of the data, which is being sent from some IoT devices to data server. So this is a actual a problem when we have to assure that whatever the data we are transferring should be secure. See, privacy and security, these two are the different things. So I have another lecture, maybe in the third lecture or 13th. So I will talk about this privacy and security of data in very detailed manner. But for now, as you have asked the question, so we should have some secure, we have already some security methods and encryption techniques where we perform these method, we apply these methods to these data before sending to a data server. It means we just encrypt our data at the IoT device, and then we try to send it to a data server if we think like there is a issue of security of the data, or if there may be any kind of attack on that device. So we are also having some secure protocols by using which we transfer our data to make, to assure its security. Next thing, if you are if you are now wants, if you want to make your career in the field of data science, then for the language perspective, you may go with the Python, as we are also working with the Python to makes our machine learning or deep learning models, to make training of the models. So for sure you can go with the Python now, and you may have some you will get some lectures, you will get some tutorials on the some online YouTube. There are various channels where you will get the content for this. But still, if you require some more details or some in a specific detail, you can mail me anytime. I will provide you.
Okay, thank you, Mr. Harshit.
Okay. So I think the queries are yes. Anything?
Yes, please. Nesta, do you have any more question? Oh,
No, that's all for me.
okay.
Thank you.
Mr. Danny, please.
Yes, thank you. Hello, Mr. Harshit. My
Hello,
name is
Danny.
Kenny. Hello, I'm a Master of Data Science student. Thank you for
Okay.
your presentation. That was really opened my mind. Very useful and insightful. I just want to ask about IoT. I think we already know if IoT is used in many things, even in high things. For example, smart.
Danny, I'm unable to hear you, the
Okay,
voice.
thank you. Sorry. I'll repeat my question.
Yes, yes, please.
I think we already know that IoT is used in many things, even in high risk things. For example, smart cars also use IoT, and maybe smart cars have a risk to our lives if the IoT system in the car has a problem. So my question is, how we can reduce or overcome this risk, especially when it comes to IoT?
Means what I get, that you want to ask that if there is some smart cars in which IoT devices are there,
Yes.
so how we can know the if there is a problem is going to happen with the car with the help of IoT? Is that a question or it is something
No, no,
different?
no. I mean, sometimes, sorry. Sometimes, maybe IoT system in the car has a problem, so it will be dangerous because the car will maybe hit something or uh, something like that. And how we overcome this problem? Because if the connection of
Okay,
Internet of
okay.
Things has a problem, yeah, I think
Got to
you.
means is if the IoT device itself have any problem, then how we will deal with that?
Yes.
Okay, so that's a very good question. So that can be resolved by the help of the concept of machine learning, where see the IoT devices is only for sensing the data, but the machine learning is used for making predictions, analyzing those data and making decision on those data. So in case if any IoT devices stops working, it means either the IoT device will not give any value or it will give any false value. So for the both the cases, we try our machine learning model to train in such a way that it will take some course of action in such scenario. So that can be resolved by training our machine learning models in such a way that it will take a suitable action if some IoT devices starts malfunctioning.
Thank you, Mr. Harshit, that
Okay,
answering my
okay,
question.
Danny, thank you.
Yes, Nasta, please. Oh, Martin. Mr. Martin, please. Yes.
Yeah, thank you, Pak Bambang. And again, thank you, Mr. Gupta. I want to know, maybe by your experience or your career in IoT, what is the some biggest challenges in implementing IoT solution in this? I mean, in let's say in the industries on in how to about the the function of how the machine learning and also AI to implement IoT in some I mean sector, like let's say in industries, or let's say in a small region agriculture. So maybe you can give us let's say best practice and also some big challenges that we can learn from your experience. Thank you.
See, in nowadays our era is getting more technological and more digitized.
Yeah.
So as far as I have seen and I can feel like whatever we are doing in the field of information technology, so we are very grown up in that. Whether we are using artificial intelligence, we are using IoT devices, means we have very matured and smart devices nowadays which we can use in multiple kind of applications. But the important things which may impact in the entire scenario is the security of the system. Suppose
Mm.
we have integrated some IoT devices in any industry or in any farming or anywhere. So if that has been attacked by some attacker, then it may give some very dangerous effects. So maybe this is the very biggest challenge, to make this Internet of Things very secure, or to make the training of such model in a very secure manner, so that we can avoid such kind of cyber attacks, such kind of threats to those systems. So maybe this is a very biggest challenge nowadays. And also there is a one big challenge with the IoT devices is the issue of resource constraint, that the
Mhm.
IoT devices are now run on some energies, like some battery operated systems are there. Then how we can make it less dependent on some this kind of energy, and how we can increase its storing capability or computational capability to make more computations or complex computations like our large system can be able to do. So these are the main challenges which we can now focus nowadays to provide some kind of solutions.
Uh, Thank you, Mr. Good.
Okay, thank you.
Any question?
Okay, Bang Bang, Mr.
Yes.
Bang Bang. So
Yes.
I think we should now close the
Okay.
session.
Okay. Once
So,
again, thank you very much for your wonderful speech.
oh,
It
thank you.
will continue. We wait for more exciting speech
Yeah, yeah.
before we end this meeting. Mr. Hannah, Miss Hannah, do you want to speak something? No? Okay. Before we end this meeting, let us take picture and also fill out the attendance form. Please help us.
Yeah, Harshit, could you please help me to? Yeah, okay, yeah, just set on this since I need to screenshot. Okay, for everyone, I need your help to open your cam. So this is I will try to take this documentation for us for our first sessions.
Mhm.
Yeah, I will wait for all the others attendants to
Okay,
open the.
so I think you are taking attention. So may I leave now? This.
Yeah, yeah. Oh, wait, Harshit. I need
Maybe
to. I need
you
you
take a
to.
photo first. Take
Just
a
only for
photo
a minute.
first.
Just for a minute. Once again.
Few
Okay,
minutes.
just wait. Just a second. Ayo, yeah, yang lain. So for the
Okay,
others,
okay.
please open the cam first. So Harshit will go before Harshit is permit to leave. Then I need to all of us
Yes.
to have the
No,
Yes.
documentation.
sure,
Okay.
sure. I'm here. No
Okay.
issue.
Okay. Yeah. Okay. 1, 2, 3 for the first time. Okay. Okay, once again. Okay. 1, 2, 3. Smile. Wait. Wait. Yeah. Okay. Thank you very much for your attention and
Thank you
for
very
your.
much, Mr.
Thank you very
Harshit.
much, Harshit, for time.
See
Okay.
you
Very
Thank you.
good,
on the next meeting.
Thank you.
Nana.
Okay. Bye bye.
Thank you.
Bye.
Next will be 9th of October, right?
Yes. Hello, Miss. Yeah, we will again meet on October 9 on the
October
same
9.
time.
Yeah.
Okay.
Okay, clear. Thank you very much.
Okay. Thank you, ma'am. Thank you.
Thank
Yeah,
you for
thank
all the
you.
participants. See you on
Thank you.
9